Check, check, check. Hey everyone. Lazy Ben. Doing mic test. Okay, cool. Right. Let's get on with it. Today, the plan is to put in trees into the content pipeline. Alright, so where are we? Default level generator. So level data generator for trees. Tree content data. Tree simulation content data it's called. So in order to end up here, we need to put a tree in the level. So we'll do that now. I'll delete everything out of the room. This gives us just an empty game, basically, an empty level. And we'll put in just a new layer like that. And then we just want to put in a tree. So we've only got one actual tree at the moment, which is difficult to see. You know, I'm wondering if we need to do some kind of checkered background for this. Maybe we'll work on that later. Okay, so I'm just going to put on snapping and put in it. It's very difficult to see because of the black background there. There it is though. So if we run the game now, it'll come in here. And once, so we have tree simulation content data. This is a bunch of stuff that we need to worry about now. Alright, so it's probably one sprite per tree, I would say. So it's almost the same as when we do the level data generator for normal data, normal sprites. So we could maybe get away with calling append sprites. I think that will work. So let's try that. So level data generator for normal sprite content data. End sprite. No IntelliSense, unfortunately, which is not great. There we go. So eSprite type tree, eSprite kind normal. What else do we want? There we go. It doesn't. There we go. Content brush instance. So we need the brush. No, we need the instance. Offset is offset. ZBias is ZBias room ID context. Okay, so let's just run this now and see if that's okay. Okay, so there's no image associated. So the data path, what is the data path? It's a texture array. DDSA. Okay. So we cannot go the normal path. So we'll do this, we'll just copy and paste it in. So this is actually texture array. So this texture array is probably one texture for every single part of the tree. So all of the trunk, all the different leaves and stuff like that. Okay, so let's just see what we get. So this just returns void, basically. So yeah, we've got 2,400 textures there for that tree. It's a big old asset, that. Most of them are tiny though. Like a 12 by 12 pixel texture. Still just want one sprite though. So is there anything we can get so all these textures in theory are the same format. BC7. They actually need to be images. So the thing is, like, this BC7 format here, I don't think the Tilebook accepts BC7 formats. So we basically need to load it into, we either need to write an image array version of this, which might be the way to go, or we need to turn all the textures into images. I think it's going to be better to write an image array version of this. So because this data path is something called a DDSA file, it's basically just a bespoke texture format that holds a bunch of textures in the one file. You know, or we could just turn them all here into images. Image. So I'm thinking maybe here we could have like an image array. Basically as a first class type. So it'd be something like like that. So let's go to texture. Look at that. And then we want to read from file with a reader. So if you look at editor, asset types, texture array, construct one, new texture array path. You have a DDSA reader. and a DDSA writer. So this is really a DDSA texture reader. Or we can have DDSA reader for we could do this potentially. Something like that. More inclined to go for that, to be honest. And then in texture, we have read from file with a reader. We do the same thing. It's basically the same apart from its image on here. It's basically the same class. Oops. So textures is images. This is image. Okay, this means we need potentially what the CPP file. I'm not going to do that. Basically the same class. Images dot T, is it? Yeah. So that's basically that. That's what an image array is. See if that builds. Nope. DDSA reader. So we want. This really does need. We do actually need to make a CPP file, really, for image. Might be able to chuck a lot of stuff in there, actually. VM types. This is just types. And we want DDSA reader writer. Where's DDSA reader writer? It's in LibVM graphics, actually. Right. So the thing what I'm going to do is rename this the DDS. No. DDSA texture writer. DDSA writer. So I wonder if we either move this into libbm or we move this into libbm. DDSA reader. So this would be DDSA texture reader. And then we would need DDSA image reader. Where would we want to put it? Maybe here for now. And that one can go away. Should really be in a file. Should be in a header, really. We could put it. Yeah. Yeah, okay. We'll put it. We've got DDS image reader there. Put it here. DDSA image reader. Put it in there. And then this is DDSA image reader. That goes away. Okay, so that we need a source file. Doesn't know about image. So we have to include image there instead. This doesn't know about binary reader. DDS image reader. Okay, so this is, we have a problem here. So image must include something that includes DDSA image reader. It does. Right. So we can't do that. It's gonna have to go in image. Where is this in here now? Let's put it there. So we'll delete that. The image needs to go in CBP. I love how it just puts it in the picks a random folder to put it in. It might be the wrong one. Okay. So we maybe just need our own DDSA image reader class file even. So we'll include image. So this goes back to being image view, and that doesn't work, just doing it on. It doesn't seem to be able to create the declaration. Ooh, that's the wrong one. What's going on here? It puts it in the reader writer, which is not even in the same lib file. It's mental. Okay. No. To make this manually then. DDSA image reader .cpp. Now we recognize it. No. I'll do this. Ah, there we go. So this is just, we don't really need types. Right. So this includes DDSA image reader now. Right, so if we just look at the texture version of this, we'll just copy it and we'll change it to be images instead of textures. So DDS image reader, so we've got texture, so we've got image, images, push, image, load from have DDS image reader. Whoops. All right. So this is DDSA reader writer. So this is also in the graphics This is also in the graphics library. I kind of want it to be in the LibBM library instead. Images. Load from memory is not a member of image. Read from memory. So the writer remains in the BM graphics at the moment. I'll probably just leave it like that for now. All right. So this needs to include DDS image writer. This needs to include LibBM DTSA image writer as well. I'll build order problem here. Right. So I wonder if I should do DDSA image writer as well. Just DDSA writer. Yeah, I'm gonna, because this is just all in one function, I'm gonna put it in here. DDSA writer. I need to fix this. Something's broken here. So I might rename this to DDSA image. So if we go to image, we've got image array. Well, an image array can send, doesn't have to be with DDSA images, does it? So yeah, I'm just going to say, call this DDSA image reader writer there and here, and then the texture one. So in LibBM graphics now, DDSA texture reader. It's going to be called. So that's DDSA image reader writer. DDSA texture reader. Texture reader. DDSA image reader writer. This is DDSA texture reader. Alright, cool. So we're back to building now. And we have something. So we have a DDS8 image reader now. So we'll put a breakpoint there. And in the default level generator, we could make make the content cache support image arrays. But first, I'm just going to go image array brush get data path. Just load it straight up there. So there's 2,000 of them. So now these are all image data. These are all images. So they're no longer BC7. Which is good. Which means that they can be used. So do we want the content cache to support image arrays? What would that mean? It would mean it wouldn't be too much work. It would be the same as... Okay. Let's make it support it. So it would be next asset image array next or ctstra.ddsa. That would be basically that. So we're saying that we're allowing image arrays, and we would need where is it? The texture array for an image array as well. And then if we just go to this declaration, this implementation here, it's basically the same. Except all these texture arrays are image arrays. Like that. We have a problem here. There's a bug we spotted yesterday with these is-olds. What I want to do, this is a bad way of doing it, because we had some bugs with integer overflow. So I'm going to do static is old age what's the good word for this? So last used frame edge. Edge. So we're going to say if last used frame it's greater than max age, return last used frame what do we want to do? How do we solve this for the content cache? Desk is old. That's the wrong one. So this. We want this logic. That's good. So return is old 1024 is old frame 1024. Okay, cool. Alright. Okay, his old is a bad. It's getting mixed up. Stage. Alright, cool. So if we just build this, hopefully that means this content cache can use image arrays now. So the default, so rather than just loading it here, we're going to go images, image array, which is kind of important because trees have 2000 textures, and if there are 20 trees in a level, that would be 40,000 texture loads. Whereas this would just keep it at 2,000 texture loads because it just reuse the same set of images over and over again. All right, there we go. So there's them as images. So I'm just going to check that in. That's good. So we've got all these images. And we just want one sprite with all these images in it. So how do we want to do this? How do we want to get the format? We could just look at the format of the first image in the image array. Or we could get the format out of the PSD file that contains the tree. So the brush in it has tree.sprite sheet that would have to load and find the so the asset file we should be able to store the tree. The asset file in there. Let's see if we can do that. So This is when we're making the brushes. Generate sprite brush for tree. So the asset file is the sprite sheet path. And then let's just delete all of the brushes. Generate all the brushes now, so the asset file is in there. Okay, so the brush is empty, apparently. Ooh, what's going on there then? That shouldn't have happened. So we do have so that has caused deleting the brush there for the tree has caused a problem with previous. Ooh, look, we have a problem there as well. Okay, so that caused a problem. So now we have it back. So it was the generating of the actual brushes. And that grass is gone as well. 4 types of grass in there, only 3. Interesting. So that is actually a bug that I've seen before that I thought was fixed, but it's not. There we go. I'll have to put that back there. I have to fix that now. So let's first generate just check that this works. Regenerate the level data and just check that the brushes do line up. Yeah, there we go. So we got all the images out of the content cache. So we have a look at that. Bug there. So that's if we generated all the images. For some reason the tree failed to generate. The tree brush. So they're all there now. So if I get rid of these and then I clear all the brushes, this force builds all the brushes. And then I look, it is working there. It did work there. Ugh. Not there though. It's really hard to see. So there it didn't. So this, to give a different brush ID for the tree. That must be what it is. Let's see what's happening there then. So basically this is broken. If you actually resave the actual sprite sheet tile with the tree in it. Let me go back. It takes quite a long time to save that tree. It's 2,000 images. That one. Yeah, the light's broken there as well, look. So there's something wrong with generating all these brushes. That is actually breaking stuff. Ooh, look there, look. Okay. Night Child, how's it going? Music sound like Windows Star. It's just royalty free, relaxing music. Boring, really. So now we're back. Now we're back to being proper. The light's still messed up though. So that actually might be a different type of bug, generating the thumbnail. Okay. So we do the thumbnail generator. Lighting layers. So the brush.origin. Something to do with this. P, what is P? The local offset. Let's just start by doing this. Not entirely sure what local offset is. Resave that. There we go, we're back now. So local offset and the origin are the same thing. So the light file comes from the sprite sheet editor. Generate lighting. The local offset is the local center. Yeah, it's not the origin. Anyway, we'll leave that for now. Tackle the bug of regenerating all the brushes. It seems to. So that's working now. If we regenerate all the brushes though, well, let's see. Let's first regenerate the level data, and we'll look at the brush ID. So it's this. And the data path is just a brush ID.ddsa. Yeah, okay, and that works. If we regenerate the brushes, so we delete them all, I want the brush ID to be the same, which it is. But there is no brush. There is no content brush with the ID apparently written to disk yet. So what's going on there? It's potentially because we haven't. Oh, it's because it takes several frames to generate that content brush because it's being rendered. That's what it is. So it isn't actually there. I don't think it is actually there yet. Oh, it says it is. It's there, but it's not been placed in the cache, maybe. Or it was put there later. So the brush is not there. The brush is empty. But it's there now. So it's a timing problem. So it's because so say when we actually generate the, where are we? On the end of the frame. That's for lighting. So when we come to generate, so the thumbnail, where are we writing the brush? So for generating the brushes, some of them take like 3 frames. And the asset compiler's coming along on frame 0 and not finding the brush, and that's because it's not been written yet. Maybe. Only the thumbnail though. So, 'cause, 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 ' Sprite enum, so sprite type. So generate sprite brush for tree. This is the one that's kind of failing. That should be alright though. So let's put a breakpoint there and then a breakpoint here, and we'll see where we arrive to first. So delete the brushes. Okay, so we're generating the sprite brush for tree. There's lots of layers. So we're writing it to text file there. So we are generating it, but it's not in the cache. It is in the cache. But it's the wrong thing. Well, what is it? So we're writing it to text file there. So if we're writing to text file, we're writing the brush. But if we were to go now immediately and get it back out of the cache, it would be out of date. And that's what's happening. So this is 9980.brush. And then we come along here and it's empty. So it's not in the cache. So it didn't exist. The text file got written. And then we immediately asked for it out of the cache. By ID, that's what's happening. So it doesn't know the path. And it's not there. It's because we're loading it by ID. So we need to actually place it when we do this. We need to place it in the cache as well if it's a brush. Need to figure out where. So we need to just trace back where this is happening. It's in here. So it's doing x.initialize. But here you see, where are we? The containers. We've already scanned content brush and determined that there's nothing in there. And then we're writing a load of brushes, but they're not actually in the cache. We're just writing them out to disk. So how do we want to handle this? Because what we want to do now is basically call initialize on it again. On the brushes. Or on the content brush generator, where are we? So, or what we do is we make sure we get the brushes at the end. So we generate the brushes and then we get them all. See if that happens. And then this comment is content brushes. Try that. So what it'll do is it'll generate the brushes and then it will load them. Let's see if that actually fixes it. So basically we're looking for the tree simulation, the breakpoint to fire, which it does, and then get all the way down here, and it's going to write the brush out, and then we will load all the brushes next because we changed the order. So by the time we get here, it should be there. It's not there. Okay. So we'll do this and this, and then content brush construct one should come later. Oh, hang on a second. So we did the tree simulation. So it didn't even call construct one. Interestingly. So what's going on there? Right. So it's here. So what is X now? It's type content brush. Initialize. It's not doing anything there. Did make them all though. So initialize. So let's have a look at this. So this is the content brush with no assets in it or anything. Content brush, empty. Arg.path. So asset editor file paths get. We got any brush files in here? How many are there? Oof. There's loads of them. 2,291. That's anything that's a brush. Okay, paths. When's paths made? Paths is made. Paths is made before we've made the brushes. Interesting. So what do we want to do here? So we've got paths at the beginning, but then when we've called initialize, it's made new files which should be put into paths. So now we're like, there's nothing in the paths there. So we load it, there's no brushes yet though. So one way we could do it is to load the paths up every time. Editor asset files. That's all that is, it just stores the paths. How slow is this to actually get all the paths? 16 milliseconds, roughly. So it wouldn't be that the worst thing in the world to get it all the time. You see, what we could do is do something like flush. Say if flush paths empty, and then so this requires, like, you know, we could call flush on it. For particular types. Right now is only content brush. So it'd be something like if, so it'd be like auto flush is false. If const expr standard is same type content brush. flush is true. Like that. It's a bit of a hack. It would be better to have maybe a list of types where that works. And that's flush. Then we generate the tree, but then we call flush, empties the paths. So when we get new paths, this should contain the brush files somewhere. Yeah, there we go, got all the brush files in there. Which means we do come into construct one, so we're adding all the brushes in now. Okay, so we'll go back to our level generator stuff. So now, if we what we're going to do, if we redo the levels, hang on, stop. So now if we delete the brushes, so now we make the brush, and then when it should exist, it does exist now, and the images exist. It's still being rendered wrong though. Here. For some reason. So that is in game bar content, the renderer for tree. So the instance tree simulation content data. Okay, so let's just have a quick look at the room. The brush ID 79980. I think that is the correct brush. It's just when it was actually red, the tree simulation had nothing in it. So it's here. So it's this bit here that's wrong. So this is loaded. Okay. So this loads an out-of-date brush as well. I believe. So this is being loaded first. brush doesn't exist. Oh, so that is annoying. It's basically trying to construct game board content, and that has in it a tree, and that needs the brush to actually load. But the brush isn't there because we've deleted it. Okay, so how do we want to handle that? Not sure. Basically, any asset that loads that needs to reference a brush won't be able to load because the brush has been deleted, not generated. Otherwise, or it just leaves the tree simulation empty. So there's no leaves. No leaf states anyway. Not sure how we would solve that. Without putting the tree simulation itself into a file, making it a file that we could load off disk. But that's kind of what the brush is meant to be. So it's to do with, so what I've done, where are we? Is I've said content brushes at the end, so refreshes use the latest content reloaded. But what I actually want to do is run the generator first. I want to run it first when we're just loading the when we're just loading the game, basically, just loading the editor up, I want to run the actual content brush generator first. But refreshes need to run it last. So it's to do with the initialize. Here. Or whoever calls this. Who calls this? Sing get. Different get. It's here. So we want to do something like auto brush generator equals instance. Well, what is it? Select one. Where's the actual call? Select type. Content brush generator from instance. What are the containers? What type do we actually want? What is the container type? Editor asset container. So we actually want to. It's this. We want to select that container first. That's just a. That's guaranteed to it. I think that's a compiler if the type is not in the list. Which it seems not to be in the list. What's it called? Content brush generator. Ooh, Dragon, how's it going? Hope you're alright. Working through some architectural problems. No. Hope you got it back. Oh, it returns a reference as well. That's good. So we want to do that. And then we want to do the content brush. What is this? Brush generator container, really. And then the brush container. And then we just want to say using container if constexpa standard is same container a brush generator container. This is the SQLite file. Alright, okay. Yeah, in case it happened, a good idea. So if it's equal to well, we can do, yeah. If it's the same, if the container is the same as that, well, what could we do? We could say using initialized containers. Just those two, really. And we could say if constexpa type in tuple v container initialized containers. So it's already been initialized. We'll just return. Else we'll do that. So this means that so this happens on startup. So we'll do the generator, then we'll load the brushes, then we will do everything else. Now let's see what happens there. Okay, so let's look at my breakpoints again. Where's the one for the animated rig? Must have gone rid of that. That's tree simulation content data. Tree simulation. No, it's here. This one. This is the one we want. Let's do that again. Right. So we're going to do initialize on that. And then when we do this, the brush exists now. Okay, that should fix it. Fingers crossed. Yes, it did. Awesome. Weird ordering problems, eh? That seems to have fixed it. So let's get rid of all the breakpoints. So now if we delete the brushes, everything should load in the right order, which means there'll be no content that renders incorrectly. There we go. Okay, Good. So now let's just go back to the default level generator here. So this is where we were working before all these bugs. So hopefully now that means that this bug is fixed. Okay, so we do need to regenerate the levels. So, is it engine config? Okay, so we have all our images now. What do we want to do though? So how do we want to handle this? We want one sprite really. So this is the image. So the format is really the first image format. So I'm gonna go if images get count is equal to 0, will return as well. Otherwise, the format do this. Is images zero. That would be the format. Oh, it's an image array. Image array. And then we'll go auto images is image array. Images. There we go. If there's no images, otherwise it's just the format is the format of the first image. Putting trees into the game now. Getting from the level editor to the game. So we do this. Brush tile bounds is the image bound. There's no image bounds as such. Do we want to do tile bounds maybe? So we could load the asset file here. Rather than all the images out of the... Let's try this. Go auto image cc get image brush asset file. And then we can get the texture format from there. Whoops. And then we could... So currently in the brush we don't actually store the tile bounds of the tree, I don't think. We could do that. Bounds, tile bounds is 0. So let's put that in. Where's tile bounds? It's below bounds, so dot tile bounds is tile bounds. And then let's regenerate all the brushes again. So now we should have a tile bounds, which is here. So that could be brush tile bounds. So I think that would be, that's good. Let's just run that through. So that tile bounds takes quite a long time to load. That tile bounds is that tile bounds there. This one. Which should encompass the whole tree. And it's relative to the bottom left corner. So this outer one is the actual PSD bounds. But we can draw a separate tile. So we can cull stuff out. Right. So now we can add the sprite in. Which is eSprite type tree. Let's do that like that. I think that's everything we need. So that just generates the sprite for the tree in the game code. So now we need to do the texture generator for it. Texture generator. So it's this for tree. Whoops. So this is split images into tiles again. We want the default tile size that comes from the config file. The image this is basically for every single, so this is an image array. Whoops. And then the images. So we want to do it for every single image. We want to go for auto image in image array images. Do this. So we want to do it for every single image. What's this? Tree simulation. And that's not correct for that. But we'll get there. Okay. So how many have we got? We've got 2,000. So we want to add 2,000 different indices into here. So now when we want to add the images in, what would we call add image on the brush tile, but one for each index. It's actually image array images. So this is brush tile book, add image brush tile range indices I think that's it. It's fairly straightforward. So we've got all these ranges here. 2,000 of them. As long as we don't overflow. There we go. Okay, so that's it. That's it for generate images. So the mesh generator for free simulation. All right, while these adverts are going, I'm going to make a cup of coffee. I'll be back in 2 minutes. Okie dokes. So the mesh generation. This is where it gets quite complicated. So what is a tree simulation mesh look like? So let's have a look. Rooms, build rooms. So the first one, add content to level. So are they all just sprites? Okay. So we've got some stuff here, level 3. Right, okay. So this is doing it a little bit differently. This is saying that we're making a sprite out of every single leaf. That's adding thousands of sprites. I don't think I want to do that. So we'll make this work a bit different actually. We do want such thing as a level 3 because it has the simulation in it, which we still need to run. So that actually, well, let's split this window apart and then it's line 465. This is in a level data generator for tree, so we need to make one of these level trees as well. Level tree. So look at this. We can actually do it the same way as we've done level sprite. So the ID is the instance ID. The room ID is equal to the room ID. Position, instance, not position, plus offset. So it's weird because this is actually very similar. It's almost the same. So I think almost the same as the sprite. So what we could do is just do sprite index, couldn't we? So this would be auto sprite index, is that. So that just points to the sprite that represents all that stuff in it, but it just needs the tree simulation, which is nothing to do actually with I don't think we do anything with the tree simulation. But also this thing called tree leaf state and all that. You do need to actually fill that in somehow. Oh, we have it actually in the brush or in the actual instance, so we can go tree equals instance get data tree simulation content data. That actually has in it the tree simulation. So we can just do .tree simulation .tree simulation equals tree simulation. I think that'll be good. If we can get it right. This is tree data. So there's no such thing as sprite indexing level tree at the moment, but we can do that. So U64 size t. So U64 sprite index, and then we'll say to do delete below. Simulation. We're using level framed animation here. Yeah, we are. That's a similar thing. Oh no, framed animation refers to multiple sprites actually. Okay, cool. So we just need to add that tree into the level. Don't want to delete them yet because it'll just cause unnecessary compile errors. So we're going to do auto trees is context level get trees add tree, just a standard move tree. Okay, so that puts the tree in the level. So now we need, what was it, 465 or something. Now we need to know where we're actually adding the mesh. So the mesh generator for tree simulation. Let's just run it and see what we have to work with. So I think we basically need to make vertices for all of these tower range indices. So let's look at the mesh generator for normal. Put that in there. See where we are. So I think this is for auto range. Well, for I in brush tile range indices. I. There's two I's there though. T. Got a lot of them. So submesh index range plus equals this. Oh no. Right. So the submesh index range is this. And then the last plus equals 4 times range.count. I think that's what it is. So it's not. So where is it? The index range is not to not. So there's going to be 24 different tiles, and tiles are 4 vertices each. So that means that the submesh is going to go up to 96. So the rect world is probably not correct, because this is using the brush tile bound all the time. I mean, it might be right. We'll figure it out. All right. So it's got 9,832 vertices there. Right. So that, in theory, is the tree sprite. I'm not sure if it's actually correct or not, but it's in the game. It's not been drawn yet, but we haven't actually written that code. Okay, so sprites. This is game now. So we've got a tree. So draw level trees in world. So what's going on here? I think this is doing some crazy async simulation thing. So let's not worry about that yet. This is really bad. Rewrite all this. So let's just put this back in now. Okay, so we should have a little box where the tree should be. It seems wrong. To start with, it's in the wrong place. So let's fix that. So this is to do with the bounding box, submesh bounds. So it's the brush tile bounds. Translating by minus the origin. So the origin could actually be built in. Not sure yet. Shouldn't be though. So let's begin by not doing this. Does that look in the right place? It's not in the right place. It should be at 0.11. Should be being drawn at 0.11. So sprite position is 1,1. Sprite local bounds. It's this that's wrong. This calculation here. So the source tile. In the texture generator. Trees. So it's where it's actually in the data generator. So this here, so I'm not entirely sure what we put here. Possible that we need many bounds. Tree data. Like we need bounds for every single let's have a look. Well, we have the positions of the leaves. Of every single leaf. And we have the trunk position. By the time we get to here, we have our source tile. So that's where it is on the image. Okay. So let's just grab this for now. Let's not use the brush tile bounds for a sec. Hang on. Texture generator. So actually, So this is relative to each individual image. So let's go to background again to here. So the source tile is not, so it's relative, yeah, so it's not relative, it's not anything to do with brush tile bounds. So I wonder, I can just do this. So we need to actually add on there the leaf position or the trunk position or whatever we want. So we need to get the tree simulation back out again, which has all the positions in. So tree data, brush tile, brush, get content, tree simulation content data. So this T let's see. So the tile range indices. We need to know what index we're in. So I think this is essentially just like or index ref. Tile range indices. Fu Manchu, good morning, how's it going? Hope you're alright. So we're getting a few too many indices now. So this is going to have to be range index. This is going to have to be tile index. This is just going to have to be character or something. This can be, well, call it counter. That's tile index. Took the kids to school. Oh yeah, lovely. Sounds great. I miss napping. Although I do it sometimes. Sounds like a nice start to the day, that. So the tree simulation, we need to get the simulation out. And that has the trunk and the leaf states. So we're going to say if counter is equal to 0, then we're going to do rect world plus equals tree trunk position, or P, I don't know what it's called. Get trunk position. Where are we? Get trunk position. So I'm going to go auto leaves, tree, get leaves, else rect world plus equals leaves counter -1 position. Y, that is. So we are assuming there that the trunk is layer 0. Which is probably not the best. So that is also not translate by minus origin. By the looks of it. And that seems wrong. Tree trunk position is literally the world position. Okay. 64, 64, 190. So that is the world. So we'll forget about translate minus origin for a second. $64, 64, 192, 288. Right. So that is in world space relative to the bottom left of that texture. Of the tile. Björg, how's it going? Benjamin 10 doing? Doing alright? In like a little bitty maths land. Coordinate system land. Takes me a while to get through this. So that's actually relative to the... So if we do position minus origin, right? That's actually relative to the tile. That's the bottom left position relative to the tile. Not actually relative to... That's maybe all we need. No, because we need to fill in these vertices, don't we? We need this tile in world space. The least amount of maths. Yeah, unfortunately you can't avoid it sometimes. You're a game engine mate user. Not being a game engine mate, yeah. This is particularly confusing because we've got quite a few coordinate spaces here. I'm not a maker, I'm a gluer. Yeah. So we don't actually know where this tile is in world space. That's the problem. What information do we need to know? And what information do we have? We need to put some more stuff in tree simulation content data, I think. That would be easier. So we need to store each part of the tree's bounds in world space. That's what we need to do. We need to store it in tree simulation content data. So it's basically the PSD image layers, I think. So it's an array part bounds. And that gets stored in the brush. It's just where do we want to actually store this now? It needs to get stored in the brush, really. Yeah, so it can get stored in tree simulation content data. So brush. Tree. So what are we doing here? We've got each layers. Where do these layers come from? Here. So it's about here somewhere. We need to basically, let's have a look. You can write it in your sleep till you forget. Yeah. Oh, good job. Yeah, I hope you're feeling okay today. Seemed a bit stressed out yesterday. Hope you're doing well today, though. So the layer has the information we need. So it's the layer local bounds, but what we want is we want the layer bounds. We want that, I believe. That or the pixel bounds. So we say add trunk. Trunk index position. Here is sleep, yeah. Alright, okay. Yeah, good. Good, good, good. So rather than just the XY, so when we do add leaf, we're doing... Why don't we just... So that's relative to the tile, which is what we want, I think. Why don't we just make these bounds? This. And that is bounds. Like this. So this is trunk bounds, 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 bounds. Then we star in the inverse width and the inverse height there as well. Probably don't need to do that. Be fine. Hey, the Quillionaire, what's up? How's it going? Got any questions? Just ask, no problem. Essentially, so what we're on? Found the exact function Ghidra uses. Ah, right, okay. Rename, recurse. Ah, right, okay, yeah. Yeah, cool. Yeah, that's awesome. Well done. Alright. So we've just changed that. So now let's just fix all these compiler errors. So this is bounds.xy. Ow. Generated quite a few compile errors doing that. Bounds.x. Sprite, so what we're doing here, game level and enter. Right, okay. Sprite. So I don't know if we want to do this. Actually. Graphiz. Oh yeah, cool. Nice one. Yeah, let us know if it's any good. Alright, so where are we here then? Generate sprite brush. But this is just local bounds now. Interesting here that we are splitting trunk and leaf as well. I'm not sure, really, we want to do that. Not sure how we want to handle that. We've got something called layer local bounds here. And before we're translating it by tile XY. Not sure. Nice one. Yeah, okay. That's a good idea. I think like debug visualization is so important for sure. Alright, so this is actually where we're working at the moment. Getting there now. It's graphs to take, yeah, I feel like, yeah, fan book. Nice one. Yeah. Yeah, I'm not sure. I don't know many visualization tools other than, you know, some of the graphics APIs out there, some of the higher level graphics APIs out there. Right, let's delete brushes. We may have potentially messed up the tree sprite sheet doing this as well. So there might be all sorts of problems with this now. Maybe not. It's really difficult to see that tree. It's weird there as well, like there is no... The leaves are meant to move. Oh, the leaves are moving. There's just barely any wind. So this is obviously completely wrong, but that's fine. We haven't actually sorted it out yet. What we do have now is correct stuff in here. So the rect world believe. So if we just get rid of this for a second. Yeah, if you can't visualize it, yeah, exactly. Yeah, I find it much better to just draw stuff out. I'm always drawing stuff out. I mean, you obviously need a renderer to do that. That's the problem. But if you can draw like lines and quads and stuff like that, rectangles, or even just like write stuff out to files, you know. So what do we have now? Let's... Oh. What do we have? Do we have the right thing now? So we have this thing called source tile, and that is relative now to the tree trunk bounds. But they're in two coordinate systems, unfortunately. I wonder if we can just... Okay. Let's do the level data generator again. We've got this. So can we do... How do we do this again? We're doing it for framed animation. I want to do this thing. Once we've actually made the brush tile. So we have the actual, we can actually cache the PSD image layers there ourselves. And that has a bunch of stuff that I would be interested in. So is it pixel bounds? So how does the mesh generator for framed animation work? So it goes through each layer. Brush tile bounds. So maybe we don't actually get out the image array. Maybe that's what's causing the problem here. So in generate textures, or in the texture generator, what we're doing is getting the image array out. Maybe we do it on the PSD image layers instead. So this is the brush tile, PSD image, source PSD layers, and that's layer.image, like that. Although it's the same. And then we'll just go to the mesh generator, framed animation. We've got one submesh here for each layer, which is not what we've got here. So let's go auto layers equals brush tile dot PSD layers. So auto layer is layers counter. So I think this is now, where are we, where we're finding the tile. This is layer. Pixel bounds. Let's try that. Not quite. Getting there though, we have more information. We have more of the actual layers information now. So that source tile is relative to there. So I think this is actually, so source tile is layer pixel bounds, maybe, and this is brush tile bounds. Let's try this anyway. No. Let's just write what we have. Layer bounds F. And we also have the tile bounds, brush bounds. So we've got auto brush tile bounds. Is that? They're the three things that we've got to work with at the moment. I think that's everything we need. I just need to work out how to get the world position of this tile out of them all. So that is relative to that. So we're going to go source tile translate, I'll just xy plus equals layer bounds f by xy. So 158 plus 192. I don't want it to actually go over the pixel bounds. $64 plus 94. So where are we? 158 plus 192. 350. So that's gone over it. So that's bigger than the layer itself. No, 350. 435. No, it's not. I'm incorrect. That's fine. So that puts it in the actual space of bottom left corner of the tile. And that's the tile bounds. So that's 0, 0 in world space. 6432. So we want to go That's wrong. That is wrong. So I need a pen and paper. Try not to draw it out. One pen and paper anyway. So that is relative to the layer. So if we add the layer bounds XY on, that is relative to the bottom left of the image. It's the bottom left of the image, not the tile. Okay, so that means that brush tile bounds needs to be the image bounds here. Get bounds. Which is 512 by 512. It still seems too high. Not quite right, is it? So that means it's 158, 119 relative to the bottom of the image. So it's not translate by origin because that's just confusing matters. So that would be 100. So that this first tile is 158 by 19, 192, 288. Okay, so let's just load up this asset in Photoshop and have a quick look. This is stumping me. Trees. And if we look at, we want the info. Window. Info. All right. Hang on a second. So this is from the top right. So 158119. Where is that? Let's turn the leaves off. It's about here. And it's 192 by 288. 158 plus 192, 200 and it's about 300, 340 or something. It's about there. That seems correct. That seems like it would be good. So that would be about 4 in the world. Okay, so that might actually be just break there. This does just the trunk. Okay, that seems kind of right. So if you do translate minus origin, we actually need to rebuild engine config. So that's too far over left. It looks kind of right in Y though. Okay, I'm going to make this easier as well. We'll just have one tile. Generator. So the tile size is 512. Break. Break. That means we're just generating the trunk now. Oops. Going on here. There's no breakpoints. Okay, so the layer bounds is that. The source tile bounds is that. So that puts it in the coordinate space of the image. Alright, I'm going to have a 2-minute break. Use the loo. I'll be back. So that puts it in the coordinate space of the image, but what we actually want it in is the coordinate space of the tile. So I wonder if that means so if you want it in the so that's the coordinate space of the layer. This is in the coordinate space of the image now when I do this. what we actually want to do is have it in the coordinate space of the tile. So we've got a minus. So I wonder if we just set brush tile bounds. Level data generator. To actually be the tile bound, which is the brush bounds. Brush bounds. I think it's that. Well, depends what space that's in. That's in world space, which is unfortunate. Do we actually have the pixel? Brush. Tile bounds, that's what we want. Hey, how's it going? You alright? Tiling going alright? Is your tiling going alright? Yeah.
Because the walls are all, it's like really difficult to get the lines right, you know.
Yeah.
It's not perfect, but...
No, what can you do? Yeah, I know.
Got me winter fuel allowance.
Yeah.
So I'm going to buy it.
Oh, lovely, yeah. Alright. So now maybe we can minus the origin. That looks good. Yeah, I think that's good. I think that is good. Right, so now let's keep it like this. But in the texture generator, we want tile size back to what it was. So this creates a load more tiles, but it should be the same bounds, which it is. Right. So let's not break there anymore. Or there. Right, so, oh, hang on, we didn't run it there. Let's run it again. Okay, so that's obviously 2. So I think what we can... So it's working for up to the trunk. It's working for the trunk, but not anything else. So let's go back to So we know now that the trunk layer is fine. So far. This layer, which is layer 707. So the source tile, that now is relative to the bottom left of the image. So that seems okay. Yeah, that'd be great. Thank you. So that is just 2.5 units up in Y. But then, yeah. So we're going to say, if not source tile F, intersect brush tile bounds. Break. So one of these is not. So they should all intersect the brush tile bounds. There might be stuff that's not in the tile. So they all intersect the brush tile bounds. Oh, wow, we blooming deleted the breakpoint. Try again. So we might have to do a trim here. That's probably what's going on. There's something in there. Look at that, that's like massively out. So which tile is this? Pixel bounds, look. Ooh, what's going on there? So that is unfortunately a bug. By the looks of it, it's wrapped. So what is pixel bounds? Is it unsigned? It is. Why is it unsigned? Right. So there's something going on here. So which one was wrong? If it was Y, wasn't it? If Y min is greater than Y max. Let's find out what layer it is first. Oh, That's great, thank you. It's layer 1163. So if L equals 1163. We're actually loading here. The tree, we are doing the tree. Did I just read that wrong? 1363. So this is obviously coming out. It's in a negative position. Min is 71. Apparently. 1363. $277.71. What's going on here then? 1363. So it's leaves copy 2. Where do we get the name? Layers, where's layers? Layers. Layers L. Array out of bounds. Layer. Okay, it's just layer. Leaves 330 copy 2. So this So it's this swap here that's messed it up. Valid layers. So it was fine until we swapped it. And then that didn't work. So what's going on there? What's going on here then? Something's going wrong with this move. So valid layers. 1363. Is incorrect. So what happened there? Oh, look. Potentially. Oh, so the valid layer. Okay. So that's because it's not one-to-one, because we're checking the pixel bound area. So it's not 1363 that has the incorrect. So what I'm going to do is just say, just copy this and just say if ymin is equal to that. Right, so this is basically being read straight out of it. So can we do so we'll do y equals standard bitcast int from ymin. Minus 30. Right, so that's what we're going to do. We're going to have to bitcast them all. I hope this doesn't mess things up. And then this pixel bounds has actually got to be integer. So the box here, so this isn't, because this is an integer now. Where's the source box? There's a bunch of problems now. The fact, well, hang on. It's just right now. It's image source box is rect_u. This is eventually going to go away. Let's see if I turn that to a rect_i. Does that create a load of problems? Whoops. Image get bounds. So I wonder if also we couldn't change all that. This would be annoying though. This would be a lot to change. bounds. So that should be rect I. Well. I was thinking maybe we keep it as rect U and just clip it. No, we can't do that really. Like if the image is, if it's a if it's a negative layer bounds, there's no pixels there. So what we need to do is go back, and then we're going to go IX min is standard bitcast int. Well, we'll do Y min first. Then we'll do X min. Then we'll do max. And we're going to say if Y min is less than 0, Y min equals 0. We'll do that. Oops. I'll have to do that, I think. And that goes back to being U. The thing is, like, if it is negative, when we come to actually get the image data out, it's going to be reading. It's going to be reading off the end of the image or before the start of the image. So it needs to be 0, really. It was this one actually that was causing the problem. No, it was this one. We'll do it with all of them. So that comes in at -30. So basically we just have to saturate it to 0. Let's do that again. So that was -30, -28. So that gives it a 0 in height, basically. Okay. So let's see what happens there. Ooh, we get heap corruption now. Alright, okay. So what's going on? And now we're causing heap corruption. Because obviously we're reading. Okay. We still need to read the data out of the file. So it's not quite this. We can't just set Y max to 0 because it needs to be. We need to preserve the width. I think we do this, and then we're going to go auto ix standard bitcast int layer pixel bounds x. Ix is less than 0. Layer pixel bounds x is 0, and that preserves the width. So now that preserves the width of the thing we need to read from. So it's just 2 pixels. Ooh. Let's just check how the reader actually works and whether that's valid or not. The problem is with that is it is a valid layer after that. Okay. So the pixel bounds are that. If the actual reader itself PSD layer reader, it just uses width and height, doesn't it? So where's the start of the... How does it know where to read from? The source, I presume. Pointer. Get pointer. Right, okay. So I think actually it's fine to do this. But what we have to do is it's not valid, basically. Yeah, so it is fine to do this. So it's fine to have pixel bounds as integers. Okay, we're gonna have to do it and then make it an integer then. Basically, just deal with the consequences. So tilebook generator, that means image source needs to be an integer as well. Image gets bounds. See, it means everything to do with images has got to be integer now. Not necessarily, no. So I'm thinking like the image. Okay, we're just gonna change that back to you. So layer bounds clip with the source box. So this is bmcast rect I. We'll just go this route. Because it doesn't make sense really for images to have negative XY. Like for instance here, it's going to read. So what's this doing? It's drawing an image rectangle. It's going to read layer image. It's going to read before the start of the image, which makes no sense. If this is allowed to be a negative number, then it's just going to read before the image data. Certainly confusing, that. It doesn't make actual logical sense. What we need to do is like if it's off the start of the image, it's invalid basically. So the right way to handle this would be to clip it. Would be to read the whole thing. Clip it. So it would be to actually probably do this check. Here. So we're going to go, if there's no area, continue. Continue. So we just won't, if any of them go off the end, just won't add it into valid layers. We won't clip it. We won't clip it. Okay, so that looks good, actually. So we should put a to-do here, really, like... Should we clip the image, the layer image? To the PSD image bounds. Main image bounds. now. Chuck it nowhere. So what we could do is like some of that might actually, some of the layer might come on to the actual main image. So we can actually clip it and make a smaller layer, which would require more work. Alright, cool. So that looks actually pretty good now. We'll check that we run through here. But it looks, the bounds looks good. What was throwing the bounds off was we have some out of bounds layer sizes. Okay. And we should have individual bounds for everything in the tree. So if we go to game level, tick room, so right now we'll just go tree in trees, auto sprite is equal to trees sprite, sorry, tree.sprite index. Oops. So we will do that here. We'll go do this. And then we want to go tree. Trunk index. So we want the simulation. So the trunk right now is just the sim. Get trunk. And then we've got the trunk bounds. We want that to be trunk bounds translate sprite position. And then we actually want to draw that out as well, a different colour. Oops. Draw that red. See if the trunk bounds is correct. Seems it could be. It's difficult to say because we're not actually drawing the trunk. And then we're going to go for auto leaf in sim.leaves, get leaves. It would be leaf bounds. Right. Oh. I'm actually drawing the wrong thing there. I really don't want to listen to nursery rhymes. Oops. Yeah, I don't know. It's obviously royalty free, innit? So it just plays it. You can go to sleep if you want. You can have another nap. That was pretty good though. It's obviously wrong by some translation amount. So the leaf bounds so if we minus origin off there, I think it will work. Maybe. That's not what I want to do though. Oh yeah, you could do that. Do it for a bit. How long's your notice period? See, that looks good to me. That looks good. So we need to build in the origin. So where do we want to do that? That is the question. Probably when we're doing the brush. 60 days. 60 days. That's long, isn't it? Let me neck. Yeah, well, count them days down. Layer.local bounds translate by minus tile world bounds. Minus tile.origin, I think. Yeah, of course. Yeah, I understand. Yeah. Crazy, innit? I'm just right in the weeds, or I have been, of coordinate transformation horribleness. I think I've got through it now. Okay. I've got like, I had like 4 coordinate systems there, trying to work between all 4 of them. There we go. That. Yeah, it was a nightmare. So you've got like the coordinate system of the leaf, but then each leaf could be, which is this yellow square, could be broken into like, because there's a mesh for each leaf potentially, if you get big enough anyway. Rather than just draw it as a quad, it will break it into a mesh to cut out all the white space. So there's that coordinate system of the actual mesh, and the one of the leaf, and the one of the actual thing in world space, and the one of the thing in the tile sheet. It's absolutely awful, but it's working now. So now you just do that. Trunk bounds translate, right position. So now we actually need to draw the stuff. So it's just draw level submesh. think. So we'll do the trunk first. Let's just sprite. Vertices, textures. Submesh. So we want the submesh is sprite index. Submesh index. Draws literally nothing. Well, let's draw the submesh bounds first. The vertices, textures. Okay, so those UVs seem very wrong. They're like enormous UVs for what it is. So let's draw the submesh bounds. So the submesh bounds should be all of the trunk and the trees and everything combined together, same as the sprite bounds. Which is good. So draw levels. So what's going on here then? In theory, we should just be able to draw this. We're not simulating actually the particle system yet. We're just. Oh, 'cause I think maybe the vertices. You have to figure out the vertices might be based upon. You might need to add the leaf position on to each vertex. Another thing is we might want to, if we want to simulate things like leaves falling off the tree, we might want each leaf to have where it is in the submesh as well. Potentially. There's just a lot of vertices. So first things first, let's just draw all the vertices out. What would it be? For V in submesh index range, or I. Just draw a quad. Canvas, draw quad in world. Vertices, I. Position. So we'll just do this for now. So I expect possibly we need to inflate it. Like by 0.1. think we need to translate it by the sprite position. I think. Yeah. So they're very big vertices. Translate sprite position. So it's the texture coordinates that are wrong. They're too big. 0.025. Alright, that seems kind of right. We could draw 4 together. So I think they come in 4s. So it would be something like auto range, submesh.index range, and then we go and go for auto equals range first is less than range dot last plus equals 4. And then rather than drawing a quad at every vertex, I want to draw basically some lines. So I draw a line in world. So we'll go and say P's is equal to vertices R plus 1, vertices R plus 2, R plus 3. Oops. And these are all actually position. And then we want to draw some lines. So we want to go P0 to P1. P1 to 2, P2 to 3, P3 to 0. What's this then? This vec2. Really, you can't have an auto for an array type. Array of a type. Okay. That does seem wrong now. That seems a little bit off. Ah, look, we need to actually translate the translate them. By sprite position. Yeah, that seems right now. Right, so the UVs are wrong. Right, so the vertices are right. The UVs are wrong, though. By the looks of things. So I'm going to do this. You should be able to draw directly out of the submesh. Which we can't because the UVs seem wrong. So, this is RGB positioning world, I think. Nope, it's not that one. XY UV in world. I think it's this one actually. So let's return one. Right, so let's return float for UV01. No, return that. Yeah, I mean they seem wrong to me. Maybe they are wrong. Maybe I can't. I'm not sure. I mean, they definitely are wrong because it's just basically drawing black. So let's have a look then. First, let's just see if that. See if this is actually going to do the thing we expect it to do. Seems fine. Seems totally fine. Right, so back in the level generator now. So this is where we generate UV dest tile. Tile index. The inverse tile width height might. Okay, well let's go through here anyway. Oh no, first things first, let's just pix and see if that texture is not just a bunch of black. Nice to only go back to work after Christmas. So, Fu Manchu, if you're still there, so are you actually going back after Christmas? Or you finish on the 19th? Or are you going to go back to work a different job? Like that 14,000 verts. Hey, the tree's there. What's going on there then, eh? Maybe it's there, it's just very dark. What's going on there? Tree's there in the in the debug. Yeah, cool. Have a nice Christmas and a good New Year, and not have to worry about the stress of work. I've just actually there's a ghost in my renderer. There's the tree texture. This is super duper dark. There we go. Maybe it's there. Maybe I just can't see it on my screen. It's kind of there, but it's, well, I don't know. That's 58,000 verts there. Try embedded, yeah. Try something new, I think. I think, you know, every 10 years, good to think about trying something new. Also, you know, it is there actually. It is there on the. I wonder if the tone mapper is just. So maybe it is there. It's just very dark. I think it is there. It's just very dark. So that means the UVs. It is there underneath. Okay, well let's just mess with the shader again. Return the colour, it won't tone anything. Made no difference. Let's do return color plus, what do we want to do? Color plus color.alpha. Ooh, what's going on there then? That's interesting. It looks like everyone possibly is referencing the every sprite is referencing the tree. So the UVs are definitely wrong. Have some experience, but yeah, okay. Even an oscilloscope. Yeah, Bitwielder does stuff with oscilloscopes. He comes on stream sometimes. He's really into that kind of stuff. Yeah, man, sounds awesome. I think it's quite. There's something quite. It's like interesting to code things for very low performance hardware. You know, rather than just games on 5090s. You know, it's good. Like, it is interesting to, like, when you've just got tiny amounts of memory and stuff like that to work with. Alright. So let's just turn all these off. And the generator. Let's have a quick look then for how actually it looks like every single. It looks to me almost like every single quad had the same UV. We'll see. So where are we getting source tile from? Wrong index, look. Range index we need. Connect to your PC to measure. Oh yeah, cool. Yeah. Cool, yeah. Sounds really interesting, that. Alright, let's see what happens here. Might have just been a typo. There we go, there's the tree. The colours look really off to me. Possibly just a tone mapper. I think it is just a tone mapper. They look fine now. It's really dark, but the actual tree is dark as well. Right. So we know now, actually, that the level generator is working. So now we can actually just put in the simulation. So we can move the leaves around. So how is this going to work quickly? Maybe we should think about that later. Just sell all that and declutter. Yeah. Depends if you're going to go into it for work, though. Might be nice. Have a look at this. Oh yeah, cool. Nice. Nice. Could try streaming full time Fu Manchu. Wow, that's awesome. 100 nanoamps. What I want to do with this, so the simulations for the tree system takes quite a long time. It needs work, it needs optimizing really. So I might just leave it. I'm not sure. Yeah, if you're allowed to, if your work allows it, that'd be awesome. Get a job where your work will let you do it. Or just do it yourself. You don't earn much money though. At least not 99.9% of streamers. Yes, I think I need to figure out how I want to update the vertex positions for the leaves. Because that is a performance bottleneck currently. Could somehow transfer it all over to the CPU, you know. Oops. You gotta work on my engine all day, yeah. Fortunately, I I'd have to pay you in coffee. And it's not good coffee either. It's cheap Sainsbury's coffee at the moment. Sometimes it's cheap Lidl coffee, which is actually quite nice. Sometimes it's Greggs, which is very, very nice coffee. Not sponsored by them though. That's my limit. Spending £2.75 on a coffee or whatever it is. So right now, the trees are in the game, but they are not animating. And I might spend some time after this content pipeline stuff is done working on updating the particle system for the leaves. Sweet trees, yeah. They look a bit different, but that's because there's tone mapping in the game. They look very dark. It is very dark. But with a... Let's see if this works. If I put like some soil... behind. Okay. So we do have there tree in the wrong position. But they're not, the leaves aren't animating. But that's, you know, I'm animating all the leaves on the CPU, but there's like 2,900 leaves. And if you have 10 trees on screen, that's a lot of work. So I might have a go later. So I'm going to do a pass on the actual game's level renderer. I might have a go at moving it to the GPU. Oh, Brill, Fambio, that's great. Great news. Get some images, yeah. The immediate problem I can see is the trees come in at the wrong location. Which is interesting. -1, 1. So the vertices... That's interesting why it's coming at the wrong location. What if I rerun the game? Does that happen? So it was just in the right location. Ah, look. It's been drawn in the wrong location there as well. So is this because... Oh yeah, will you do as a coffee? That'd be great, thanks. We're not... It's something to do with origins, this. We're not drawing it offsetted by the origin. So let's just turn on here again, turn on all this stuff again. Dr. Elliot, how's it going? Hope you're alright. Welcome back. I'm on slow but intricate mode today. I'm doing stuff that warps my brain a bit. It's doing alright, yeah. I'm working on content pipeline. Basically like getting stuff from the level editor into the game. So I'll just have a test level here. The goal is to get this rendering in the game. The light's broken though. And fix bugs as I go, you know. So I'm just working through the different content types. Yeah, that light. There's a bit of a bug there with the light stuff. But yeah, it's going alright. Slow. It's slow at the moment because it's quite like fiddly. It's quite fiddly. So the game's actually drawing it in the right place. By the looks of things. It's this. Oh, and now I've got a little rectangle problem there. What is that all about? It's the editor that's now drawing it in the wrong place. Need to be pushed. It needs to be like pushed up to the origin, you see. I haven't done it for Dominator trees yet. Oh, cool, yeah. Cool, cool. Alright, I'm going to have to start again with that because I'm not entirely sure what happened. So, let's just start all over again with brushes and everything. So, I'll add a new layer. Okay, so that's definitely wrong because it's completely in the wrong place relative to the mouse. So let's have a look at the game board editor. And then we want preview for tree simulation, which is just preview for normal. Stamping normal. No, preview for tree simulation. Paintbrush position push trunk.bounds.xy. Ah, okay. Brush origin. So when I make the brush, so for some reason here now, we're basically subtracting the origin 2 times. So when I actually make the brush, we did change what we did to the bounds. Oh, thank you. That's great. Cheers. So where are we? The local bounds was subtract the origin, which I think is correct. So what all that means is that this has to just be back 2. No origin there. Great. There we go. So if we put it at 1-1, it's very hard to see. Let's just draw in first some floor. Take off the snap. And then, let's put the tree at 1-1. 1-1. Right, stamped it in the wrong place. Preview is right, stamped it in the wrong place. It's here. So it's the renderer that's wrong. Where are we? Game board content. Tree simulation renderer. So this is just because now we're actually baking in the origin into the leaves. Into the leaves and trunk position. So say floor, full floor. So we'll just put in a bunch of stuff. So we'll do 2 trees. And then we'll do 1 of them. 2 of them. 3 of them. And then we'll do some flag stuff. I'll do that up here. 2 flags. Two of them. And then I want at least 2 tile sheets of stuff. And then we'll put some grass. We'll just go crazy with the grass. Put all of them in. Put that around the back. Bring that forward a bit. Oh, look at that. That's a bug. Go onto there, it starts drawing grass. Alright. So we'll fix that as well. Let's see if that ends up in the game. That seems good. We're at 30 frames a second though. That's because we're drawing all these meshes out as well. Okay, so let's get rid of all this stuff for now. to be fair, actually. Just do this. Oops. We'll draw the level submesh straight away. We need the submesh. So let's get rid of that for now. Whoops. That's not what I wanted to do. Okay, we're still drawing a bunch of quads somewhere. Ah, here, look. Right, there we go. So just have a quick check, a quick compare. I think we're good. I think we're good. Apart from the colours are very muted. That's okay. Good. Alright, so I think that's trees in. Except they're not animating. Let's move on to the next thing. We're back in 2 minutes, have a break, and then we'll move on to the next thing. Just thinking maybe we can make them animate, because it wouldn't take very long. I don't fancy starting a whole new one today. So it would be 3.tick 3.simulation tick canvas. Why do we need the canvas? And what does this actually do? Oh, so it adds weather effects and stuff which it needs to get from the canvas. So for this to work, we basically need to rebuild the vertices with the leaves in it. Here's the thing, like, the leaves constantly move, which means the vertex buffer that is generated constantly needs to be uploaded to the GPU. What we need, what we actually have to do is render the leaves in a separate call, which builds a dynamic vertex buffer. So I've got a dynamic one as well, which is meant to change every frame. So it would mean doing that, which is we could do. But the thing is, like, we could just do the simulation on the GPU, set the position there, but that requires a lot more work. That's probably what we'll do eventually anyway. And this is perfectly set up for that. Almost. It would require a we couldn't do draw level submesh. So let's try this. Let's just try this. So we'll do tick. And when we do tick, we need to get the leaves. Right. And then we need to go through each vertex. Would be I and submesh. Well, how do we do this? Before we need to go through each 4 vertices essentially. For I level. For auto I equals submesh range first I is less than submesh dot range dot last I plus equals 4 essentially. And then we need to get our 4 vertices out. Which is vertices I plus naught dot position. And they form a quad. Now I'm going to take a reference because we're going to move them. You can't do that. Arrays of references are illegal, apparently. I'll do it this way. So that makes a quad. So I'm presuming the leaf position, we have the leaf. So we need to get the leaf. It's leaves. I over 4. Like that. So So that gets the leaf that represents that leaf position. This is actually first plus one, because the first one is... Oh, no. First bunch of them actually are the trunk. Don't know how many though. So that means that the tree needs to store the index range of the trunk, at least. And then we know that, well, it needs to probably store the index range of the trunk and the index range of each leaf. So it'd be something like array, that'd be index range, trunk indices, and array index range leaf indices, like that. So we'll save that. So that means that when we build the level, we need to actually start this somehow. Need to get the level tree back out. So level data generator. So we make this thing called a level tree. How do we find the level tree again? There'll be a bunch. We need to go through all of the trees in the level. How do we do that? So this happens once per brush, but there might be multiple trees in the level. So the tree needs to know so the tree's ID is the instance ID. We need to get the instance back out and find its brush. No way of getting the instances here though. Interesting. I think we just have to basically, in the brush tile, we just need an array of tree indices. Really. So it would be array size T tree indices, and then this would be auto tree index, and then we would do brush tiles index dot tree indices dot add tree index, like that. And then when we do the mesh generator, we need basically this. We need to go for auto tree index brush tile dot tree indices tree. So we'll get the trees out. Auto level trees equals level get trees. Level trees tree index. So we have our tree. Just gonna say counter is 0. So that's going to be a range, some kind of range. So I think we'll do this first. Is the submesh index range. And then we're going to do tree.trunk indices dot last plus equals 4 times range dot get count. Dot leaf indices dot add submesh index range right. So that fills them all in. No. That's dot first. We'll do this. We'll push it. And then we'll do this. Okay, so let's see. Let's just put a breakpoint there and check. And then when we get back to here again, okay, cool. So that's the ranges for the individual leaves. But what we also need is a range for all the leaves. And we want individual leaves. Plus leaves indices. Okay, so where are we? Do tree, leaves indices first. It's the tree trunk indices dot last. Tree leaves indices dot last. It's the same. We'll set them both to be the same. And then here we just need to go set the last one to be the leaf range last. All right. So now, here, this is actually the tree. So this is the tree. Leaves indices first. So that's basically all of the tree vertices. And that's not I over 4 anymore. We'll do do that. Let's leave L. All right. Okay, so this is wrong now. So this is, I'll have to say, I in tree, leaves indices. I know we need to go back by 4, don't we? Need to go 4 at a time. So I like that. That's it. First and last, that is wrong. First is 96, last is 4. So that is wrong. What's going on there? Why is that wrong then? Well, it's not coming up in the debugger, so I'm going to guess it's not built properly and try again. Oh. DDSA. Where are we? Texture. Texture reader. Banana. Okay. So the tree now. Here we go. Check when I actually. Oh, shadow in there. So this is level tree. So it's 96 and 4. It's like this is not executing properly. There we go. All right, there we go. So we can go through. So the first leaf is at index 192. Is it vertex number 192? Okay, so all I'm going to do to make sure this is correct is just do this again. So it has to be plus sprite position to make it into world space. All these P's. So this is pointery stuff now. To be like that. Oh, no, I can't do that. Hang on a sec. No offset. Do we have draw lines in world? Oh, can't do that because it's... Okay, we just got to do plus sprite position on all these. Okay. Right, so we have going out of bounds. 9372. Oh no. This is high now. The one Don Ron, thanks for following. Hope you're alright. Got any questions, just ask, no problem. Still going out of bounds. We'll do that for a second. We'll get rid of that for a second. Got stand up in and out. Oh, that's awesome. First comedian I've ever had on chat. I bet you're nervous about that. Or do you mean stand up as in a meeting? I know they can't. Our meeting, yeah. Yeah, I hope you're doing all right. So you're at work at the moment. I'm just working on content pipeline stuff, getting stuff from the level editor into the game right now. Like, so this is the level editor, and the trees actually animate. You can see the leaves move. But in the game, they don't yet, because I want to do it a different way. I want to, I think eventually do it on the GPU, because it's actually quite performance heavy, because there's like, a tree can have multiple thousand of leaves, you know. So I am on with that. Make use of a texture atlas. Yeah. Yeah. Let's look at 3D dev. Alright. It's actually just 2D, this. This is alright. But yeah, texture atlas, yeah. Part of the content pipeline is to do that. Is to build the texture atlas out, which is what's happening at the moment. Like, it's all relatively straightforward and hidden away, that kind of. But yeah. So like the level editor. So you got, there are a bunch. So this is the content browser, and so this could be considered like a texture atlas that you would make in Photoshop or something. And then, you know, there's tiles around the individual brushes. I call them brushes. But then when this goes down into game data, this, you know, that texture atlas doesn't go with it, that PSD file. It looks at the level and looks at what's in it, and then makes a texture atlas out of what's in it in the level. So you're not pulling over unnecessary art, you know. Yeah, exactly. So it's like pull just this tomb building, and just one of them, even though there's 3 actually on the level. And then there's like a mesh generator, so it's not just a quad. The level compiler goes through and like builds a mesh around it to cut out all the white space. You know, where alpha is 0. So these end up being actual meshes. So that's part of the content pipeline as well. So it isn't just a cached big atlas of all the assets. It's created on demand. It's created when it changes. So the idea is that if I was to change this level and then relaunch the game, it would then detect it's been changed, rebuild the atlas, pack it down into a data package, and then that is what's used by the game from then on until the level changes again. I'll show you it actually. So if I run pics, you can see what the actual texture the level compiler made. That's it. That's what it made. That one there. So you've got like this explosion thing is individual frames because it's just a video that. So that takes up a lot of space. And then there's like everything else really. And then all the leaves for the tree, because the leaves are individual, because it's a particle system. They're individual textures for all the leaves. But it like breaks them up. So if you look at the wireframe, you can see the mesh that it made. See, it actually cuts out a lot of the white space. So they start off as just rectangular tiles, but by the time they've been through the pipeline, they're a bunch of, it's a mesh of rectangles essentially. What's the renderer logic constructed at high level? So you've got the canvas, which is like where you send stuff into the renderer, and that can do all sorts of things, like draw lines, like for instance, and then that gets all batched up together, and then so you can have multiple canvases, and you can tell them to, so you can draw to a canvas and then draw the canvas anywhere on the screen, and then so when you do draw a line in World, it builds up basically a list of commands. So you could prepare a canvas and then draw it over and over again if you want, multiple frames, or you can like empty the canvas and draw it into it again if you want to. And then at the end of the frame, the canvas gets what commands has been issued, and then processes them all and builds meshes and stuff like that, sorts them Z order and stuff like that, and then that gets basically like pushed into the renderer as is, like the actual renderer. So the renderer takes all this canvas information, and then that gets sent to whatever graphics API you're using, like DirectX 12 in this case, but could be anything. You could write a Vulkan 1 if you wanted, and that just receives basically a list of render commands in the order it's meant to draw them. And you just have to basically, whatever API you're using, you just have to make sure that all gets drawn to the screen somehow. So there's like a front end and a back end basically. Yeah, the canvas is the responsibility of the canvas is to get like a set of draw commands and prepare them for the back end of the renderer, I suppose. So it doesn't know necessarily that it's what it's drawing. It's just like you draw these vertices using this material or whatever. It doesn't know that it's like drawing a animated, well, the animated rig it probably would know it was drawing. Well, maybe, I'm not sure actually. It's just big meshes. It just gets meshes essentially of data that you just draw with. But yeah. So the renderer takes the canvases, because you could have many canvases. For instance, so you've got the game canvas here, the game canvas and the HUD canvas and the overlay canvas, and they're all separate canvases. So the game canvas draws all of the level, and then the HUD is drawing this thing at the moment, this radar thing, but it would draw anything in the HUD. So if you had a menu open, it would draw that, And then the overlay canvas has generally got all of the debug stuff on it. So, you know, like the idea is currently this all just gets drawn to the window, you know, but the editor, for instance, you can have canvases that just are over a part of the window, but they all have the local coordinate system, you know. Can it do 3D stuff? It can do 3D stuff, yeah. I'm gonna, so that once I've done this content pipeline stuff, I'm gonna move on to, I'm trying to make a game as well. And I spent like 6 months making all the, like, preparing all the gameplay systems and doing pre-production and all that. But next on my plan is to build the real game UI, and that's probably going to have some 3D stuff in it. So yeah, it can do 3D. I don't know if I'll be doing loading models and stuff, but I'll be definitely doing some like 3D meshes and some decent 3D lighting effects and stuff for the UI. But yeah, I could do models if I wanted to. See, the first engine. No, I've made loads of engines in the past, yeah. I'm more of a tech guy than a game developer, I suppose. You know, making game tech is what I enjoy. And this is like the first time I think I'm going to try and make a game with one of my engines. Before I've like gone so far in the engine and then been like, oh, I could do that better next time. So I've written another one. But this time I'm going to try. I've got enough time now to actually try and make something proper with it. Yeah, cheers. But yeah, like I'll show you the editor. So this is a canvas, you know, this bit, and then this bit down here is also a canvas, and then this tab section here is a canvas, and then the game board is also a canvas. So like you can do like, it doesn't have to be like levels. So you've got like a canvas for there and a canvas for there. This is like a behavior tree. So this drives, when I was doing gameplay testing, this was the combat tree that I made. But yeah, it's like the engine can do all sorts, like, yeah, lots of AI behavior stuff, and then it can do dialogue, multi-choice dialogue systems, dialogue trees, quests, cutscenes, all sorts of stuff. Yeah, exactly, yeah. But you know, it's what I enjoy, you know, so I don't mind. This is definitely the best engine I've made, the best 2D engine I've made. Because even though it is, you know, I can have 3D render paths, it's predominantly gonna be 2D art, with the exception that of some of, like, the UI is probably going to be in a more 3D thing, because it's going to be sci-fi. So I want kind of like, you could do like, I don't know, spinning things in 3D space and stuff like that. But yeah, it's definitely the best 2D focused engine I've made for sure. So yeah, what I'm doing now is just I'm gonna get these leaves to animate, but there's loads and loads of them. I think it's about 2,500 leaves a tree. So if you have a forest, that's going to be a lot of stress for the CPU to do. So we'll probably I'm going to do another pass on the game level, like the thing that renders out the game level in the game. And I might try and put these onto the GPU maybe. But for now, I'm just going to do it on the CPU. think. If I can. So I'm just getting each leaf, which is a quad. And then I just need to set the position to the tree simulation's leaf position. So yeah, something like that. So I need to get the leaf. It's leaves. This was actually going out the bounds of the array before. I'm not sure why. Yeah. So that means there's more. Ah, right. Okay. Because some leaves are not 4 vertices. Right. This is actually a bit more complicated. So what it actually is leaf indices like that. So each leaf has a bunch of verts in it. They should be broken into quads though. So for auto I leaf range. And then the leaf is leaves L. And we'll just say 0 like that. Dude, the one done, Ron, do you do game dev as well? Is that your thing? Okay, so that needs to be let's go over 4 vertices. I undeclared identifier. So that's going to go from 96 to 100. Alright, let's see if this gets overflow problems. Okay, there we go. So it's the same, but we have each leaf now. So we have the position. in theory of each leaf. So if we do we have leaf dot bounds. So let's do canvas, draw quad outline, or draw quad in world. Leaf dot bounds. Let's draw it white for now. And we'll draw that here. We'll see if this is actually moving. See where it is as well. It might need to be translated. The sprite position should need to be translated by the sprite position. There we go. So it's really tanking FPS there. But that's because we're drawing so much stuff. A lot of stress on the CPU. Yeah. It's mostly overdraw, I think. Not actually that many draw calls, but they're all crunched on top of each other. So that's what's causing the problem. But the thing is, it's just debug drawing. The goal is to like set these positions, really. So we need like the rest positions of the leaves, really. Because a leaf, I can't just set individual corner. Because some vertices are made up of more than one quad. So what we kind of need, you see, is the leaf bounds. We want like a delta. A delta, really. So I can just be like plus delta. Which is how much it moved. But the leaves do scale as well, so it's not quite as straightforward as that. I think we do have scale. We do actually store the scale. So we do actually have the delta there as well. Translation and scale. So maybe we just store translation delta. So this is leaf translation delta. Whoa. We're not scaling though. So actually, it's not that at all. We don't even need to actually, just so I can visualize it, but I know it's right. There you go. So, doesn't have the scale though. Scale would be more complicated, really. So we need to know the global or the local, the mesh center. Oof. Oh, we've changed actually the leaf stuff, haven't we? Need to regenerate the levels. Alright, there they are animating. It looks alright without doing scale. And we're still on at 60 frames a second. I mean, there's only 2 trees. And maybe we don't, maybe we take out scale, because that would be probably a big... that would probably help performance a lot. Maybe we do that. The great thing about this is, right, not the drawing, but this is actually all thread safe. So we can do this. And then we'll just do the drawing later. So these actually need to go there. This section though is thread safe. So how do we want to do this? Do we want to do 1 tree per thread? That seems a little bit wasteful. We can do like, I don't know, like 10 trees a thread or something. Let's just see how long this takes. So it's like half a millisecond to do two trees, and this is a pretty fast CPU. So obviously it could be better. So let's, to begin with, running 1 tree on each thread. Check. Oops. It needs canvas. I just want to check that it's going to be. Let's just do this. It's fine. So we'll do 1 tree a thread. So in theory it should be half. Maybe half. Yeah, so 1/4 of a millisecond a tree there. So the simulation, now we're not doing scale. See if we can speed this up a bit. And see really what's going on here. So I don't really know what's going on. This old stuff. Not really much is going on with scale. So that means we could have, on an 8-core processor, up to 8 trees running in 1/4 of a millisecond. So basically what we probably want to be multi-threading on each leaf state, on a subset of leaf states, rather than in each tree. Let's give that a go. So let's, if we do this, I believe it just runs it directly without actually running on a new thread. So where were we? Pre-simulation tick. So we need to know how many leaf states there are and divide them by how many cores we've got. Do we have a little helper to help divide arrays? Get job batch. See if we can use this. I haven't used this in a long time. So auto batch. Get job batch. Thread count. I don't know. I have 32 threads. This. Job count. What is job count? How many jobs? How's that different from thread count? Jobs per thread. Job count over thread count. Alright, so this is just how many things you want to do. So that's leaf state count. Output. So I think this is meant to be used like this. Job batch while. Yeah, that'd be great, thanks. Good tea. No, tea's fine, yeah, cheers. So that's like this, I think. And then the job batch has got a start and an end. So we do run job. Or 2 J batch dot start batch dot end. And then we do this. But we need to get the state. J. I think that's it. No idea. So what we'll do is we'll do it on one thread first. And then we'll do this. Like this. And then we'll flush jobs at the end. So, to be fair, we have to do it like this. For auto tree in trees. Or it'd just be like this with each trees. Arg.simulation. canvas. Like that. And then we do flush. And then we run this. Like that. And then we do flush again. So, let's just quickly see if that job batch thing is working. So you're going to do 0 to 75. How many are there? So 2, 4, 1, 9. Roughly 75. So 32 times 75. 2,400. Yeah, and then it will just probably put the last few on. See then. Okay, that's not very fast at all. It's taking half a millisecond. It's using 1% of CPU, so it's not working. Oh, it's because we're not turned on the multi-threaded yet. Oops. There we go. Oof, crash. End is completely junk. Oh, it's because batch has to get passed in by value. Okay. Batch. What do we need then? This and batch. S buffer. So what do we need? Definitely need S buffer. And G buffer. Alright. So that is 0.19. Barely using any CPU. So we need basically fewer cores, more work on fewer cores. 0.15 milliseconds. Right, let's just chuck in loads of trees then. See what happens. See, the editor can't really cope with this. Thank you. That's great, cheers. So that's 1 millisecond for all those trees. Wow, the system's going a bit mental there. Actually looks a little bit like the mesh is a bit destroyed. It's 2 milliseconds on 32 cores. It's probably 16. So interestingly, it looks like it's another bug there with the particle system's too big. Oh, it's not that. It's like up here. I see incorrect meshes. So we're at 30. That's whoa! Look at all that. So what's going on there? So we're at like 1.1 milliseconds there. We just run it all on one core. Seven milliseconds. So it's a lot faster. But the simulation seems wrong. Yeah. So let's not tick them. That seems right. Let's just do one. One tree. Oh, that's one leaf state. One tree is actually here. Doing that. So it's definitely taking more than one tree there. So what's going on there then? just my eyes? They're moving. They're moving. Is it just that tree that's ticking? Let's move that up there like that. So we've got leaves moving down here and up there. Oh, hang on. This is not the right way to do this. The trees. Yeah, that's it. Still moving all of them. Something I'm not understanding here. Does every tree reference... Oh, it all references the same mesh. That's the problem. Each tree has like leaf indices from 96 to 9. Right. That's the problem. This is a problem with this. Because it's per brush. One submesh. One submesh. Many sprites. Is it? No, it should be one submesh per brush. Right, so this is because the submesh... One submesh per brush, but it's actually one submesh per sprite. Where are we? Right. It's one submesh per sprite. What we've got there is... No, it is... No, that's right. It's one submesh per brush. And the sprites all share the same brush. So that means that this, unfortunately, cannot be a sync. Which is okay. Okay. That means we can't do this either. We need to actually pass in the deltas when we build the mesh. So I do have canvas, draw tree, draw level tree in world. So what I want is another draw level submesh where I have vec2 deltas or offsets or vertex offsets. I want that. So I'm just going to copy this for now. And when we do the tick, it has to actually build an array of offsets, of deltas, of translation deltas. So we're going to go array vec2 leaf translation deltas. And this would be leaf translation deltas dot fill with the state count vec2. Is that going to fill over and over and over? No, I don't think so. We'll check. And then this is leaf translation delta for J is equal to state translation delta, like that. So now this isn't a thing. Tree leaf simulation. Get leaf translation deltas. Like that. then this would be tree simulation, get leaf translation deltas. And that's no longer a thing. No, that is a thing. That is a thing. Probably need to rebuild the levels actually doing this. We've changed the data layout of the leaf state thing. It's going to happen over and over again. So, what I want to know is where we have. We end up here. So this basically this one needs const standard span effective deltas vertex deltas. D is vertex deltas I, and then this is D, like that. We do need a that needs to be in the header. That now is vertex offset. Okay. So I think we will probably end up moving this to the GPU eventually, because I think it would be faster. Oh, there's only 2,419 of them. Okay. Ooh, because it's one per leaf, isn't it? This is complicated, isn't it now? It's one per leaf. Not one per vertex. So we need this really. Bees must ask, how's it going? I hope you're alright. So we want T-array, vec2, vertex offsets. And we want that to be tree, leaves indices, leaf indices count. What is it? The leaves indices dot count. And then this needs to do this. And that is that. BeastMosX, thanks for the subscription, mate. That's fantastic. Thank you. 2 months. Much appreciated. I'm doing alright, thank you, yeah. I'm just working on a content pipeline for the, you know, so you get the level editor and you build the levels out, and then that all ends up getting compiled down into game data. I'm just working on trees right now. Ooh. Without trying to crash it. Triggers. Alright, yeah, cool. So we're off that. I'll show you. It's got 9,000. See if I can just... I'll show you. I'll turn the trees off a second. So it's running pretty bad because I've got loads and loads of trees in the editor. But let's just get rid of that for a sec. I'm trying to just optimize a little bit the trees. So yeah, these ended up being the triggers. So with a little icon, so you can make triggers just by dragging like that. You can delete parts out of a trigger, and then you can set its type, so monorail station, but there'll be different types of trigger. And then you can put events on them, so you can say like broadcast chest. So if you wanted it to be a chest, select the chest type, and then you say this trigger, and then the condition could be that you are inside this trigger. So the playable character is inside this trigger. If the playable character is inside this trigger, then you broadcast a chest from this trigger, basically. Yeah, it's cool. But the actual, like, all of the content types that I have for the editor are currently, you can currently author them now in the level editor. They're all working. But what I'm doing now is trees. So this is a tree here. And each leaf is a particle. So you can see them move when the wind goes through them. So what I'm doing now is putting like loads of trees on the screen at once and just seeing if I can speed up the simulation of the particle systems, really. I mean, it's only a stopgap. Eventually I want to do it on the GPU eventually. So I just need to get that working. But yeah, I hope you're doing alright. Much appreciated for the subscription. Much appreciated. What have you been working on today? Anything good? Okay, so that is minus submesh dot index range dot first, I think. And that should stop that crashing. As long as we get through without crashing, which we didn't. Oh, thanks very much. Yeah, I'm looking forward to it. I think it's going to be really good. Like, is it last? Tell you what we'll do. We'll do J. Oh, we have offset there. It's just offset. Yeah, I think it's going to look good. Once we get this content pipeline stuff done, I'm going to switch my focus back to the game. And we'll start building out the game for real. What's going on? $9,000. So there's 9,000 offsets there. That seems correct to me. Yeah, you too, man. Thanks very much. See you later. Enjoy your study. So that's 9828. 9732. Interesting, so there's more vertices than offsets. Which is not proper. So really, this is for in leaf dot leaf range count. It's really that. Oops. Okay, doesn't like that. So we've got 9732 in vertex offsets. How many leaves are there? That looks kind of right now. Nine 828. Nine 828. 9732. What's going on there? Oh, because we need to put in, it's not just the leaves. We need to put in the trunk as well. Okay. So it's kind of two calls really. It's one for the trunk. But there's only one submesh. So we need to put in vertex offsets for the trunk as well. Trunk indices. Count. That's just submesh. Index range dot count. We actually need to add this. It's all part of the same submesh, you see. We need to add a bunch of zeros in for the trunk, so it doesn't have any offset. So 9828, 9828, there we go. It's taking 0.8 milliseconds, which is alright. That many trees. It's only using barely any CPU. This would kill my laptop though. But the simulation is working. So let's just simulate. Well, let's just check actually. What I want to do is make sure that we're not growing massively the delta, the vertex offset thing. We are. So we're going to go empty. I'll speed it up a bit as well. Not really. We have some winds to come through. Doesn't really seem to be. Can't really see anything. Not really moving. They are moving, but not very much. Let's just do 10 times. Okay, so they definitely are moving. But they're all responding to the wind at the center of the screen, I think. So what is... How does this work then? D, world P. So I think tick is going to do const vec2 position. And then world P. I'm just going to get rid of that. And this is just position. Oops. Set world position, get rid of that. We have to capture it. All right. This is right. Tree simulation.tick. This is P. This is paintbrush position. This is just vec2 blank. This, I'm not sure. We'll do vec2 because this is gonna go eventually. Right, gonna have a 2-minute break. Use the loo. I'll be back. Okay, so when the wind goes through, I want all the trees to react like that. That's what they're doing, yeah. They're all reacting one after the other like a wave. So that's taking about a millisecond. This is in debug as well. So I wonder how long this is taking. So that's taking a millisecond. That's taking like 0.8 of a millisecond roughly. So let's just do hardware concurrency, is that what it is? Thing is, what does this actually do? How fast is it to do that? But we're still running at 24 frames a second, so there's more to it than that. Let's do this full. So let's do tick. Do tree simulation. Let's call this tick sync. And we want basically a tick as well. Actually, we want a tick and a tick async. And if we look at the previous version, that's just like this. I think what we're gonna have to do is manually remove so that's for auto state in leaf states. Do this. Take the asyncness out of that. We'll do J. So to be fair, this should... I wonder if actually the deltas should not just go in, it should put the trunk ones in here as well. We can make this a lot better actually. A bit too late in the day to do that. Okay, so now we have an async call. Let's just see how long it takes to do this. This is building the vertex buffer and everything as well. It takes 21 milliseconds. So most of the frame is like in here. It's mostly probably in here actually. In draw level submesh. No, it's not. So it's mostly in here then. It's mostly in here. Nope, it's not mostly in there. What is it mostly in then? There's a lot of stuff in here actually. Well, let's just do all the tree stuff. So Summit is expensive in the tree stuff. Not sure what it is though. I wonder if it's the allocating that. Let's try that. Still 20 odd milliseconds. What's going on there? Ah, let's make it just an ordinary array. We'll just reuse over and over again. Is it really that? takes less than a millisecond. Um, it must be in draw level submesh. I have to remember that this is happening 38 times. It's a third of a millisecond, so times 10, that's like 3 milliseconds. Yeah, so it's maybe that. A third of a millisecond is quite... So it's probably here. Yeah, it's all in there. So that's super duper slow. So let's have a look. Let's just build a release build. Can I include file DDS image reader? Reader writer is. So we could build it on multiple threads. This as well. Want to get it faster. I mean, it's 60 frames a second in release. Just under. I think we'll probably do it on the GPU though. It's 10 times faster in release. But it's working. We've got trees in, which is the main thing. Won't worry too much about performance right now. Let's do that. Don't really want to static there. This is not final code. This is not going to be any code really. Eventually this will all get changed. But what we have now is we have the ability at least to do the transform on the GPU, if not the entire simulation on the GPU, which we will eventually get to. Awesome. So let's quickly, last thing, delete the room. Just do a nice test room with a bunch of stuff in it. I'll put in a new layer. Floor. Do floor. And props. So, let's just draw this. What I want to do is actually get rid of those as well. Bit of a bug there, I can't grab onto that. Can't click that handle off. Okay. There's a bug there. Need to fix that. So if I drag onto the game board, it draws grass. That's not what I want. Do a couple of trees on there, on there. All right. Oof, crash. So what's going on here then? Two 420. Oh, it's starting not at. So this is actually tile index. There we go. We got all the trees and the leaves move. So that's good. Obviously this is not great. We need to think about this. Like when we tick it, we kind of need to pass in the submesh as well, and then we can do all this stuff in the tick rather than do it outside the tick. We do have trunk indices though inside the tree. Yeah, we'll work on that. I'm gonna have to call it a day now. It's been a long stream today. It's been good though. Got trees in, which is awesome. They need a little more work though. They need a little more work. You just want to be able to go tick and then draw. None of this stuff. But we'll get to that. Alright, great stream. So hopefully